The universe is huge and full of mysteries. It keeps expanding and revealing amazing things that make us question our place in it. Since 1929, scientists have discovered that we are deeply connected to the cosmos. The elements in our bodies were actually made inside ancient stars. By 1957, people began to realize that the night sky is more than just beautiful. It's also a powerful and complex part of the universe. Yet, despite its wonders, many of us don't think much about it until something unusual happens. One such case is Betelgeuse, one of the biggest and most mysterious stars in the sky. Betelgeuse, a red supergiant, is over 640 light-years away from Earth. It's so massive that it makes our sun look tiny in comparison. Even at the speed of light, it would take more than 640 years to reach it. If we used normal spacecraft speeds, it would take over 12 million years, a time longer than all of human history. Recently, scientists have noticed that Betelgeuse is acting strangely. It's been shaking and pulsing in ways that raise concerns about its stability. Although stars may seem calm from Earth, they are not. Betelgeuse is known as a pulsating red supergiant, meaning it grows and shrinks in cycles that can last from 10 days to over 2,000 days. These cycles change how bright the star looks. For example, in February 2021, Betelgeuse became one of the dimmest it had been in years. This happens because its surface temperature is lower, about 3,500 Kelvin compared to the Sun's 5,500 Kelvin. Even though it's huge, its cooler temperature means it gives off less light per area. Betelgeuse is nearing the end of its life. It's running out of hydrogen, the fuel that powers stars. As hydrogen fusion slows down, the star's outer layers expand, and helium builds up near the core. This causes another type of fusion, helium burning, which creates heavier elements like carbon and oxygen. But this process is less stable than hydrogen fusion. It causes the star to pulse and release powerful stellar winds that blow away parts of its outer layers. To study Betelgeuse, scientists use tools like photometry and spectroscopy. Photometry tracks how the light changes, while spectroscopy breaks the light into different wavelengths to study temperature and motion. With computer models, researchers can simulate what's happening inside the star, including convection, where energy moves from the core to the surface like boiling water. One of the most important forces at work in stars is the balance between gravity and radiation pressure. Gravity pulls inward, trying to collapse the star, while radiation from fusion pushes outward. In Betelgeuse, this balance is breaking down. As hydrogen runs out, radiation weakens and gravity wins for a while, shrinking the star's outer layers. But this raises the core temperature and reignites fusion, pushing the layers outward again. This back and forth causes the star to expand and contract, changing its brightness.